a lot of different things, which I'll get into later, but first I want to talk about what's inside this wiki. The first thing is a set of standards. Yeah, so just a wiki that summarizes the state of the art of the field. So problems, approaches, solutions, the description of the field, the summary of the state of the art, etc. A Git control repository of everything that's relevant to the development of this field. A forum with customizable channels for any kind of discussion, and a set of child frames which are each investigating a specific part of this field. So standards, this is the wiki I was talking about, include the following pieces of information. Like I just said, description, summary, list of subframes, which are just child frames, list of open problems, and for each problem, a list of approaches to that problem. Anyone can fork a standards document to create a new frame or subframe, which basically means we can capture the state of the art of a field, and then anyone who disagrees with a particular part of it can fork it and go in their own direction. Anyone who wants to investigate a more specific issue within that frame can create a child frame. And every normal scientific action within this framework enters the knowledge graph according to a unified ontology. So again, why are forkable wikis useful? Everyone can see the state of the art of the field at any level of specificity at any point in time, which means you can see exactly what needs to be done, what has been done, and where you can help instantly. This is really good for onboarding into and between fields. A lot of the sort of makeup of our disciplinary silos are just like the lack of explicit information about entities or fields available to anyone who's not been an expert. So basically, what you go through in grad school is building this sort of mental map, which is naturally created by this, of just like, what are the problems, what's been done, what's worked, what didn't work, what needs to be done, what are people doing, etc. If we can make this explicit, anyone can see it instantly and then start contributing. Yeah, so what things can be a frame? Recap, a frame is the sort of wiki concept I introduced earlier. Fields, subfields, sub-subfields, etc. Problems, approaches to problems, methods, concepts, and theories. Basically, any entity that requires a definition in relation to previous knowledge and is the subject of collaborative work by a bunch of different people. Yes. Communities can be built around frames. One definition of a field is just a group of people that's working on the same problem. Usually, a lot of the market inefficiencies that come from this process derive from the fact that the people working on this problem have different incentives. So private labs want to keep their research private and competitive advantage over all the other private labs. Academic labs want to keep their credit so they can publish and get credit later on. Independent researchers don't have a lot of money and don't have a lot of resources. So sort of like gradient, like with very extreme poles of experts, grad students, and laymen, and the difference between literally just how well have you defined this mental map in your head. The cool thing is, a lot of you guys have probably talked about so far, with Web3 protocols, we can enable collaboration between these groups in the form of granular contributions. So like TLDR, anything you submit, whether it's code, notes, opinions, papers, micro-publications, reviews, whatever, you can get credit for this and link it back to your wallet, which means we no longer have to publish giant papers through giant journals and have it take 2 years to do peer review. Yep, everyone gets credit for their work. So here's a concept that may be a little bit difficult to explain. Feel free to ask questions about this later. But basically, there's 2 ways I'm focused on of getting new ideas and building on existing knowledge. The first one is recombination of existing ideas, and the second one is a more specific exploration of an existing issue. So both of these things can be defined in the wiki document, and then approaches or new frames can be linked to those. Basically, you get a network of forks, merges, and links, which builds a knowledge graph, which can be traversed by an AI, which can continue building the knowledge graph. Yeah, so here's a way to sort of, I guess, grab papers on the internet and tag them according to frames. So each frame becomes a tag within the Halogen network, which essentially means that, like, if I create a frame, which is like a field, and let's say this field is I can go on the internet, go on archive, and pull up a Chrome extension, which basically lets me like looks at the semantic content of the abstract, the title, and the authors, looks at what I've been engaging with in Halogen in the past, and recommends a tag. If I select this tag, it adds the artifact directly into the, adds the artifact directly into the frame, which basically means each frame or entity in the knowledge graph is populated with a lot of specific information from all over the internet at any point in time. Yeah, so here's the cool thing that can be enabled with DeSci. This is just that like tag documents can be turned into knowledge artifacts, which have a state and a persistent content identifier and can be indexed in an open state repository. Basically, if any of you guys have heard of DeSci nodes, this is one thing they're focused on. We could, with Halogen and with DeSci Labs, we can turn anything into a DeSci node, not just a PDF. Like again, code, notes, opinions, reviews, comments, etc. Everything can be given a persistent state identifier. So the cool thing about this is that if I do something, it's given a name and it exists in a network. And anytime anyone copies this thing, replicates this thing, or does a similar thing, it's linked to this one place in time, which means we find out what worked, what didn't work. We basically have a representative knowledge base. So things Halogen can do. I like to summarize it by calling it Web3 data, which is unified ontology for knowledge graph from like a lot of different information by just providing unique identifiers for entities. And these are frames. But things it can do practically are like polymath projects, creating a market for tacit knowledge, and I'll skip over this one for now. Yeah, so like I just said, granular contributions enable us to or through like linked approaches between objects which each have their basically means like if you create a knowledge artifact and I cite that artifact and your thing later proves out to be wrong through decentralized review, for example, that information is communicated to me. And let's say this chain perpetuates itself across like n number of links or something. Updates will be probably of those links. Yeah, should I talk about this? One thing that's useful in biotech right now, or one big issue in biotech, is that people's like opentrons or lab robots have protocols that they all have to write themselves. So there's a lot of reinventing the wheel because everyone's keeping everything secret. But there are some like low level pieces of information, like whatever the molecular equivalent that can be shared or for biotech, this would be useful. Yeah, I can skip over this. Decentralized peer scale. So if we have this wiki structure, we can forms for a field. And if you think about what peer review really is, does this look like it's in accordance with what we already know? So if in the standards that I described earlier, we've defined what we already know, how to, and then we can just diff check basically against the sum of what we know, diff check a new knowledge artifact against the sum of what we know. So we can review really quickly, allocate it, and also make it semi-automatic with language models because we're literally just checking semantic content. Does this map or does this not map? This is like not necessarily checking for like anything like that. It's just like a quick yes no check, but it so one thing you can do if you have this tagging system is you can create a sort of attention overlay where you're looking for every instance of a given artifact on the web, how much attention people are paying to it. And if you can all this, you can say, okay, this person's an expert, a lot of experts, probably good. You can do this to quantify how well looking to find something, you can see what people are paying attention to and say, okay, this is creating a lot of citations, or okay, people are paying a lot of attention to this in a way that's completely separate from the journal ecosystem. Polymath for problems with unclear solutions. So the core idea here is, sorry, the first time this was and how I think, where they like created a math problem and on their blog and said, okay, in the comments, people should post partial solutions, ideas, and approaches to this problem. And they solved it. And they did this again a few more times. The cool thing is, I think this is applicable for this sort of framework is applicable for many more things than math problems. And if you have a network where people can define the sum of what we know, define problems, you can like mark something as an open problem, and different people can create different approaches to that problem. A funding DAO can put a bounty on the solution to that problem, which basically means like any kind of problem anyone's having can be solved in a distributed way, using expertise from a lot of different places. Yeah, that seems to be it for this. Oh yeah, the other cool thing is private labs and academic labs who, like I said, don't want to share all their work, can partially open source problems they're having to other people in this network without revealing all of their information. Just because since there's a unified ontology, they can like publish part of their frame and say, okay, we're going to pay you guys this much to solve this problem for us, and it can be solved in the polymath method that I described earlier. Yeah, solved without revealing everything, which basically means anyone can partially open source anything they want to. And when they're done, a private frame can be modularly published to the public knowledge base. Right now, this isn't possible because every knowledge graph looks very different from every other knowledge graph. But if things are done in a sort of unified way, we can have composable knowledge graphs, basically, where like I can create something on my own and then push it to the public network. People can work directly on the public network. And the sum total of this work means that we can eventually train a language model to traverse this network and generate new hypotheses, approaches, connect deeply related concepts that humans can't see, look through giant volumes of data and find what's related, what's not related, basically superpower our knowledge base. This would enable a superpowered knowledge base for AI design. Yeah, so just to reiterate, the way to interact with this is defining a problem in relation to what we know already, which is the sum of all knowledge that I described in standards. Collaborate safely with everyone who's working the same problem because we have granular contributions linked to your wallet. And the result of this is a knowledge graph that's traversable by an AI. That seems to be it. Okay, I'm not sure how much time I have left. I guess I can take questions now. If anyone has any.
Of course. Jeanette, please.
A few slides back, you mentioned that you could see what people are paying attention to, and how do you view that? Is there like wallet connected to these nodes, or how can you trace what people are paying attention to?
Wallet connected to these nodes,
or how do you know? Because you don't know them by name, right? You're just saying.
So okay, so I should clarify.
Okay, attention overlay. Yeah.
This is starting out as a Web2 project.
Okay.
Yeah, so
okay.
It's more like people are paying attention to things on Twitter.
Right.
Like Twitter is like a discussion platform for archive, right? Discord is sort of a discussion platform for archive. You can look at these things and trace like the literal piece of semantic information through these private networks, or I guess they're sort of public networks, and see in sort of a more manual way at first who's paying attention to what and what things seem to be discussed in what ways. This doesn't necessarily have to be linked to like, we know who you are and we know everything you've looked at and we're like tracking you. And I hope it doesn't turn out that way.
Right. Well, it is AI. That's why I was wondering.
I will say that the AI is mostly going to be used for generative modeling, like just generating new things. Not so much tracking people.
Okay.
But at some point, I'm very much open to involving wallets directly and linking them to people. And like once more pieces of knowledge start moving directly onto this network, we can start tracking things in a more holistic way. But until there's enough information on this network, it's not possible.
Okay. Thanks for clarifying.
Are you familiar with akasha.org? Akasha, A-K-A-S-H-A, I think it is. Okay. And then also, and how about Protege? Those are three things you might consider looking at. You can ask me later.
Phil, can you provide any context?
Oh yeah, great idea. Context.
Phil, what is present context on what Akasha does? Or
sure.
Well, they basically, my daughter gave it to me and I read through all of it. And it's, near as I could. So, well, all right. Those of you familiar with Hermann Hesse's glass bead game, it wound up being a formal mechanism for organizing knowledge, and it was published in the 1930s. This guy was inspired by it, came up with a wiki approach to do this thing, but and allows you to go on and connect and reconnect knowledge throughout this entire wiki. SciCorp was established originally back in the 70s. The way knowledge was organized was in terms of a rule systems. The rule systems wound up reaching an epitome with a company called SciCorp based in Austin. There, what they've been doing for the last 30 years is taking common, ordinary, everyday knowledge, putting it inside this thing, and allowing an AI to go on and generate new concepts from it. Protege is a project out of Stanford. It allows you to go on and create and maintain your own ontologies. There are a lot of them out there, and in fact, they could go on and be joined together into this kind of structure you're talking about. So there's a lot of, I at least am familiar with these three, and there are more out there, mechanisms of providing hierarchical structure on top of knowledge and having an AI walk over it. It might prove useful to you in your project going forward.
That was great, Bill. And I'll just mention as well, like I think fair data principles are all about trying to structure data in a way that's more interoperable, that follows that standardized ontology, so that you can do a lot of these really cool, interesting things. So kudos. Please.
Hey, couple things. One is around the incentive structures of contributing to the project. I guess I'm wondering, obviously Wikipedia has a tremendously successful model where there isn't really an incentive structure per se, other than like, I'm feeling altruistic and I'm going to contribute. But for something that's seems to be just start off a bit more, other than this is the history of the hamburger, something a bit more intensive to formalize an ontology and connect it to other things. So I'm wondering around the incentive structures that you're going to build in to encourage network adoption. And then completely unrelated, but how do you view the, I guess this is more of a philosophical question, the concept of knowledge per se, of like, yes, like pure mathematical concepts of knowledge are maybe not refutable, but a lot of other concepts, there are people, theories of the mind, theories of, anything above that. There are people who think the 100% opposite, and especially in context of economic theories, political theories, philosophical theories. How do you deal with people who are like, Israel versus Palestine, objectivity versus subjectivity?
DeSci, right? It's like summarizing what we know and then arguing about what we disagree on. Right? This is like the core reason I've been talking about standards, which is just like, sorry, I should have clarified this in that, but basically it's just like, you can separate total bullshit from disagreements in terms of how much it links to what we know already. Knowledge becomes more established the longer it exists, right? And this is something that's quantifiable to some extent. Which means basically, you can imagine as work proceeds, by the way, I'll get to your first question. Remind me what it is after I answer.
Sure.
Yeah. But if we can like by naturally running this engine, like by people publishing things in journals and on our and we're putting this into a summarized document of what we know, and this is reviewed by experts, just like a textbook. That's actually a pretty good range to think it into. And anything new that's built on this textbook is linked back to the old one. Let's say I completely make something up and it doesn't link to like the basic principles of physics, right? This is an easy way to tell if this is bullshit, right? But then there's the disagreements about like, I don't know, mRNA vaccines, right? Like there was a scientist a couple years back who, what did she do? She discovered some new technique for creating vaccines, and everyone disagreed with her, right? But if she could have linked her approach to what she knew already, and everyone agreed that this was known, it's not total bullshit then, right? So the key idea is just like defining what we know, working that, and creating new approaches that are now linked to what we know already. The first, I think your first question was about incentives.
Yeah, incentivization of adoption and participation in the network.
Yeah, so the way I sort of think about this is I'm very open to like learning about new incentive mechanisms because Web3 is not my area of expertise. But I will say that like the system is designed in a way that's amenable to the way that work is already created, right? So if you're just doing what you already do in the public archive and discussing stuff and summarizing those things, the science, right? If these be put into a knowledge graph that's has a very standard ontology, it's not that you're contributing directly to this project, it's just that you're doing what you normally do, and it's structured in this way, like magically, basically. There are a couple people that'll need to like validate things and write standards, but these are the same people that write textbooks in fields already, like Goodfellow for deep learning. There's someone like this in every field or for every entity. Those people are, I believe, just happy to do that. But definitely would be useful to think more deeply about like direct incentivization.
In terms of grounding of knowledge, there are a couple of things you might look into. One's called superwater, another one's called cold fusion, and the third one that you might want to look at is reproducibility in science. There's an argument being made now, especially in biological sciences, that 80% of the reported results cannot be reproduced. There's another place called alltrials.net that you can look at where they discuss in particular the problem even of reporting the information based on stuff that's done. So I cry when I go on and look at this because I think this is the way it should be, but it's not. That is, a lot of the results that are out there you cannot trust. You cannot go on and trust the results that come from unsubstantiated sources, and worse, you can't trust the results that come from substantiated sources. And one of the key problems that comes up is nobody has budget out there to go on and try out the experiments where breakthroughs have been reported and just test and see, in fact, whether or not it's bullshit. So, and also in terms of writing the knowledge graph, Wikipedia recently had a scandal where there's this woman basically wound up meticulously putting in every sub detail inside of Wikipedia, drawing some false conclusions, and had it sitting there for, I think, on the order of 15 years until finally it was unearthed and uncovered. So again, understanding where this information comes from and validating how it fits into the real world is an issue with systems like this.
Yeah.
Is an argument.
Yeah, you're absolutely right. I've been thinking about it a fair amount, but I think we'll think about it a bit more. One of the things you can do is like verify identities of sources. Like if I'm Stanford's Bible Club, and I'm posting something to this network, I have like my own frame, and let's say I'm the only one who can contribute to this. So it's not completely open. It's not that everyone can contribute. And if you create an entity, you can set the permissions for who can add stuff and who cannot add stuff. What I will say about reproducibility is like, if you're doing something on the cutting edge of a field, a lot of the approaches you try will not pan out, will not replicate. And a lot of this is just due to like, sure, like bad intent, bad incentives, but a lot of this is literally just like, you're doing something new, a lot of new things won't work. But if you can only get clear results from things that do work, I don't know, it's kind of screwed up. But I will say, if you have this sort of overlay of like theoretical context around knowledge, you can start to pick out, what's the best way to put this? So sort of my view around this is just like publish everything, have it safely attributed back to you. And obviously most people won't publish everything, but if you can, and if you can have an agreed upon framework for what we know or don't know, with some degree of like, yeah, certainly that's it. We can start to evaluate things. If we have this huge volume of stuff on archive, for example, but we have standards that we can dip check against, we can start to make sense of it in a low level way. It's not a problem that we can say, exercise extreme rigor on everything that comes into the system, because what ends up happening is you also crush novelty. So there's sort of these like design issues that you're dealing with. And I think the best solution to this is just have like a baseline knowledge base that's not very accurate, have a baseline checker to make it a bit more accurate, and then you have journals that are like sorting out bullshit from not bullshit or novelty or value from this. But the problem is you need the base layer to exist as well. Otherwise you end up with the system we have right now, which is not very good.
Natasha, maybe you could tell us a little bit more about how far Halogen Cloud has progressed. Do you guys have a working product out there? Is it? Do you have partners that you're interested in working with for like your early stages?
Yeah, so no, I don't. I would really like some though. So if everyone has a potential collaborator, please send them over to me. Concept has progressed quite a lot since I started. I think 4 months ago, I started out with like a 30-page white paper talking about reproducibility issues and why I hate journals and why this whole thing is like irreducibly like fucked up. And then I realized this isn't a product. So I've been starting to work on a product. I have a working MVP that I don't think anyone's going to use. So I will say it's not quite works, but it's not great. That's where we are right now. I'm raising a right now I'm thinking like long AI research or yucky AI alignment research. Yeah, that's where we're at.
Doing research yourself that you think would apply to these things?
I think I'm gonna start with you.
Sure. Well, so I appreciate it. And let's say that the partners that you're most interested in right now, system.
Like an engineer that has expertise in language models
Mm.
or Web3 stuff. It has handled the whole stuff. I'm a bit out of my time. Yeah, I think the beta testers I sort of have access. I don't know how much time I have left, but
8 minutes, but no rush.
okay. Yeah, so when I was 16, my mom was diagnosed with like I don't able to create a cancer. Insane. Imagine what everyone had access to this and it was working optimally. So that's sort of how I got interested in this problem. I do remember having a lot of issues with like why entities or ontologies or like why isn't there a state of the art for a certain field of research? Why is everything else that are flung? Started building out some different tools. One of them was like expert layman definition creator, where it was like I read a paper, I highlight something, I say I don't know what this is, and the expert's like, oh, you can pay me this much money to tell you what it is. Like a bunch of little things like this, which I didn't end up going with.
Urban Dictionary, was it Song Genius for science? What's the one that lyric genius? Rap Genius. It's one lyric from a song. You have like certain lyrics from a song that are like highlighted.
Genius.com now it's annotate the world.
Ah, there you go. Well,
Fluid dynamics and environment and like okay, what statistical methods are valuable, what like can we classify all of these things? And I remember like, reading these papers and being like, okay, I don't have the background to understand this, so I googled this word. I googled word with like this word college. And I remember just heard about the surrounding as well, but fairly structured. Yeah, after. Bad to me. I think there are some other things as well. Fantastic. I did some stuff with videos and like to build all my physics equipment. And it turns out it would be built on one.
Mentioned that one earlier as well, that there is no incentive to publish a study where the outcome was not what was expected, or it's considered a failure.
Yeah.
Do you have any thoughts around how you could do that? Because from an economic perspective, the investor always wants it to work, right?
Absolutely. Yeah. I will say one thing a direct solution. One thing we can do is create a system that's separate from all the tangled incentives of our current system, which doesn't seem to be one we can exit from at the moment, right? So if we have a platform with a lot of respected scientists and a lot of funders and a lot of reviewers and standards for how all of these things are done, we can start to at least altruistically do some of these things and build in incentives on top of this platform. That's decent. Yeah, that is absolutely.
Just one.
Yeah, one other thing, this is something that I've been thinking about a lot for fixing kind of the problems that you are describing here, would be publishing your methods before you do the experiment. I think this would be a great way to someone to chime in and say, oh, I tried this, it didn't work. You should use this dose, not that dose, etc. And then it also allows you to kind of report your results more, it incentivizes you to report your results. Whereas right now you can try and experiment 9 ways, it works one, you just publish that one. Right. So I think that would be an issue.
It has a content identifier every time this method has been used, every experiment is linked to it. Right. So like this goes both ways, absolutely. That's a great point. I will say that my view on this is just like build the infrastructure for a complete system that exists by itself. And then we can start implementing a lot of these like strategies and testing them. Like for example, publishing your methods before doing the actual experiment. It's just a great idea. A lot of these ideas can be implemented. Yeah.
I would love to highlight just one of the other cool DeSci projects I've seen is run by Angelina Lesnikova. It's called DeSci. And she was talking about if you're running a clinical trial for a study where it doesn't get published, well, that's still valuable data that you collect in that clinical trial. Make that available to others and let them run different research on the same data that's been collected. It seems like it's a massive opportunity because I would assume a vast majority of data is never published or never made available. So your modular system it's really exciting.
I would love to.
Yeah, for sure.
Okay, but
Sure. Any final questions? Well, I know you said that you're not actually like super deep into the Web3 technology part of things, but what made you said you're actually building your application Web2 first, which I think is very smart, like get the product working. But what makes you really excited about the, let's say, Web3 part of it?
Decentralized funding. Like my core excitement about all this stuff is just let's build a stable system that's like better, faster, stronger, and super powered really with the AI, right? But the only way you can do this is if you get humans to collaborate and coordinate in a way that's like seamless and optimal for everyone involved. And a lot of this I think can only be done if you have identity attached to a wallet, things like this. And if you can carry that identity with you anywhere you go, if you can keep your identity secret, like ZK proofs, for example, a lot of these new ways of establishing trust between people is really what excites me about it.
And you'd had one other comment earlier on, it was something about the community is the foundation before you can actually have collaboration.
Community structure is a precursor to collaboration.
Right.
So if we got like you and me are the same and we've got a group of sames around us and a group of difference over there, that's better than if we're all mixed together.
Interesting.
Yeah.
Yeah, it's your tribe effectively. So I would ask, have you started your own community for what you're doing at Halogen Cloud or?
I would like to. That's a very good idea.
Yeah.
Yeah.
Well, in the meantime, I've been telling everybody here, we have our Telegram chat for DeSci SF, just for other people in the Bay Area. Blockchain for Science is my favorite Telegram chat out there for DeSci, but join the conversation and throw your ideas out there, and you're going to find so many people that are excited and excited to collaborate with you.
It's a great idea. I'll definitely do that.
Cool. Well, thanks again, Natasha. Let's give her another round of applause.